Hello everyone. Today we are going to discuss the topic of algorithm. My name is Mayank Bhatt and today we are going to discuss algorithms. So, what exactly an algorithm is? So, algorithm are the set of instructions, or we can simply say that algorithm is a step-by-step procedure to solve a particular problem in which we require some input which after execution produces outputs. So here you can see the flow chart that there is a input which will be provided to the set of rules, and then by applying these, by execution of these, we it produces the output, or we can say the desired output which we want in our algorithm. So moving towards the more after defining more definition of algorithm, then we can see that the computer is used to solve a real life problems which are first identified and designed before being programmed for a computer. Algorithms are used to design the solutions of a problem. Algorithm is also a tool for solving any computational problem. A sequence of instructions which is applied to solve a computational problem is called algorithm. These instructions are applied on some raw data called input, and solution of the problem produces is called the output. The algorithm must reach their concluding state, that is, they must terminate after executing certain number of instructions. So these are the basic information about algorithms. Now, how we can express the algorithm, how we can write the algorithm. So for expression of an algorithm, we use pseudocodes, as well as we use a flow chart. So there are two options we have. A pseudocode is just like writing in English language along with some programming. So in this way we can define the algorithms in two expressions. So while we are using the flowcharts, we have to use some different types of symbols like ellipse, parallelograms, rectangle, and diamond, and some directed arrows. So here in the slide you can see that the ellipse which we are using, symbol we are using, is only denoted for start and end, or beginning or end of the algorithm. And then we are using some parallelograms which will store the inputs and outputs, and then for the instructions we uses rectangle box, and for conditions we uses diamond box, and for the flow you can see flow of data we uses directed graphs. So here are some algorithms example. We have a problem called finding sum of two numbers. Then you can see we have written a program for that problem, and after creating the logic, we have designed the program, and now we will write some algorithm for that, so that if any other person have faces the same problem, then they don't have to again work on building the logics. They simply go and search about the algorithms already designed by some other person, and just follow the instructions what are given in the algorithm. So you can see here we have written a pseudocode for this algorithm for this problem, which states that at the first step there is a beginning, and then you have to read the inputs of two variables a and b. Then we have write the logic, which is c equals to a plus b, and after the execution, the added value will be stored in the new variable called c, or other variable called c, and that c variable will be our output, which we can print or display whatever is needed. You can write anything in that, and then we must stop the algorithm. So this is the basic structuring of pseudocodes. Now we're moving towards the flow chart. We are neighbor neighbor diagram. You can see that there is a flow chart given where we have uses eclipse symbols for start and stopping the algorithm. Then we are using some parallelograms for the inputs and outputs, and the instructions equals to a plus b goes in the rectangle box. Again we are seeing one more example. You can see here again. Now the problem is we have to add 50 numbers but only odd numbers. So the sum of first 50 odd numbers we have to produces. So we have to generate an algorithm for that. So we have generated an algorithm where we start the algorithm, then we initializes some values to the variable sum and n, and then we have written the logic sum equals to sum plus 1. Then again we have written the logic which is n equals to n plus 1. You can see there n equal to n plus 2, which is a incrementer, you can see. And then we have to repeat the third step and fourth step again. I have just misprinted here 4 and 5. It is not 4 and 5, it is 3 to 5 until n is less than equals to 99, and then the value will be stored in the sum, which we can later print also, and then stop. So here in the flowchart you can see also in the flowchart you can see that sum and n is whose values are initiated with 0 and 1 is used in rectangle box rather than using parallelograms. Why? As because when we are using parallelograms, when the variables already have the inputs, now you are initializing the value inside the variable. So it is just an instruction for the computer system. So that is why here it is termed as a instructions. So for that we have put it in the rectangle box. After that we have created the logic sum equals to sum plus n, and then you can see that we have used the diamond box where we are checking the condition that whether the n is less than or equals to n. So if condition is true, then it will again the repetition will be go on, and so, and then we write the algorithm in the sum variable. So this is the concept. Then one more example we can see that for example we are using a linear search. Here in the PPT you can see the binary search, but first we should understand the linear search. So what exactly a linear search? So linear search is simply we can say that we have to check each and every element of the array or the input one by one, step by step in sequential order. But there is an option that we also can reduce the time interval by, as because you can see that when we are using sequential order, then we have to, the worst complexity will be big O n, where the number of element, that's much time we have to take. But to reduce that time, a new algorithm generated, binary search tree, which is simply what says that we have to find the search interval. So what we have done that first we have to sort the particular elements of the array, and then the first location of the element and the last location of element will be added and divided by 2. So that will create the midpoint concept. So in such case we find the central element, and after finding the central element we are comparing that central element with the key variable which is j, and then we realize that, then find that the value is smaller. Then if the value is smaller, then the whole search interval will be towards the left side of the m, and now m becomes the last value of the whole segment or the whole search interval. So again we have to calculate the locations by adding a and m's location and then divided by the 2. So we get the again central element. Then again we have to check that element, and then after that the same repetition will go till we find the key element, which is j. So this is the way, and this is the concept of algorithm which we have to establish, we have to learn very well. So that's it, that's all from my side. Thank you very much.